Data fans, I recently had to prepare an interactive Python presentation in 2 days about generative AI and agents to give to managers and tech leads. So I created a GCP project, enabled Gemini access through Vertex AI, and installed the Google GenAI and Google ADK libraries in a new Python project. Then I built a micro Streamlit app for each GenAI feature to demo, like function calling, MCP servers, and Google RAG engine, which I grouped into a single Streamlit multipage GenAI app for easy navigation. I eventually integrate everything into a multi-agent chat with Google Search and BigQuery by using Google ADK. You can watch a demo of this interactive workshop in the link here, I think. Before diving into this code breakdown on how I quickly build my GenAI demos in Streamlit and ADK. This is a Streamlit multipage app where I pull all of the GenAI demos that I want to show to managers, developers, or AI skeptics. Each of those pages is an interactive Streamlit app, which means here I can edit my query in real time and then click on that button to submit it to a Google Gemini LLM and wait for the answer. And here it is. All of those pages, all of those small applications are accessible from this top navigation bar. So I can jump from LLM response to structured output, from structured output to function tools, or directly to the fine-tuning page. Or you can even find this button in the bottom right corner, which enables me to jump to the next page in the navigation bar. Structured output function tools, which makes this like an interactive PowerPoint all in Python. If you want to create something similar for your talks or tutorials, let me break down the Streamlit code for you. If you don't know Streamlit, it is a Python library to quickly build web applications. I mainly use it to build prototypes, MVPs for product features, or anytime I need a frontend for a Python library like LangChain or FastAPI. The way it works is you've got a Python script on the left where you can write basic Python and call any Streamlit component you want to display in the UI, like an st title, an st image, or an st page link. Then you run this script using the Streamlit run. Don't look at this file name right now. Just imagine it's Streamlit run of hook.py here. And then your app is going to display in a new web browser. You can see your title is here, your image is here, and then your page link appears in the bottom right corner. Now, this Streamlit app has live reloading, which means if I add an st_write of 1+1 and then save the file, Streamlit is going to rerun the script from top to bottom. So it's going to redisplay the title and the image. Don't worry, it does some optimization, so it's not actually rerunning them. And then this st_write of 1+1 appears. You can see it here. It's the number 2. Yeah, number 2. This is the minimum you need to understand Streamlit. It reruns from top to bottom whenever it needs it. So this is a single page application, but I want to do a multi-page one. So let's build this multi-page app inside our streamlit_app.py file at the root of our project. Now you don't need to call it streamlit_app.py as long as you run the streamlit run command with the file name associated like test.py or app.py file. This is just a community convention. If you upload your project to GitHub and then link it to Streamlit Cloud to deploy it to the internet, by default, Streamlit Cloud is going to reuse the streamlit_app.py file. So I think all of our main entry points are just named this way. Let me scroll to the bottom of the app, and here you will see a set of pages: hook page, URL page, LLM page, function call page, MCP page. Each of those page definitions comes with a file path to the actual Python script. So here, app LLM schema outputs, I will open and check that here is my Python script for the schema output page. Here's mine for the LLM page, and here's one for the fine-tuning page. Each page also comes with a title and an icon. It may be an emoji or a material UI icon. And then when all of those pages are defined, I sort them inside ST navigation to put them in the navigation bar. It can accept a list of pages or a dictionary of sections to a list of pages, like this agentic AI, GenAI, and agentic GenAI. This ST navigation will appear in the left sidebar. Here you've got your agentic AI is here, your tools for GenAI is here, and then your going further is here. You will also see the icons and the name, like this title resources is here, and then you've got your next steps here, and then you got the associated icons like the book 2, which appears as a book 2 here. You may see here the position top, which puts the navigation bar at the top of the app, but because Streamlit is responsive, if the screen is too small here, it's going to move the top navigation bar into the left sidebar. Finally, after selecting a page like this LLM response page, our script reruns from top to bottom, so here, top, bottom. Inside ST navigation, we store the page selected, this LLM page, and then we run the content of the script, which means the LLM page gets run. Let me show you the LLM page. This page is going to run after the streamlit_app.py file. This builds you a portfolio of small Streamlit applications. When I discover a new Python library, I usually build multiple small Streamlit applications, one per library feature, and when I'm done, I pull all of the apps I want to reuse into a single multi-page Streamlit app. All of those apps are independent. All of the objects you see defined here, from this client, this form callback, or this user prompt variable, they are going to stay contained into this script. Because every time you change script, the Streamlit app will rerun from top to bottom, and this script will not run because we are not now running the schema output page. Anytime you want to preserve an object across reruns or even across pages, you can put them inside this st session state variable. Objects inside session state are preserved per session. A session being here, we are in a session. When I change page, I'm still in the same session, even if there was a page rerun. But if I hard reload this page, I create a new session, so everything in session state is wiped. Since this is an app about GenAI, I do want to create a single Google GenAI client to Gemini and share it across every application or every page. So I come back to my streamlit_app.py file, and here I initialize a GenAI client using a Vertex AI project and some secret project ID and project location. After creating this Gemini client, I store it inside the session state dictionary at the client key. I can then print, if you want to see it, I can print the st session state as JSON. I think there's a get JSON, right? As a to dict, and if I display it, you will see the Google GenAI client here, and I've got some other values from the LLM page that we'll see later. Where are those secrets managed? In Streamlit, you will find those inside the .streamlit/secret.toml file. So here you've got your project ID and your project location. If you're managing your app from Streamlit Cloud, there's a whole secrets management page dedicated to setting secrets. And if you're managing your own Docker or Kubernetes deployment, you may need to mount this file inside your running container instead of bundling everything into the Docker image. Now let's get back to our LLM here. Basic LLM page. Let me go to the bottom. We've got our title here, LLM understands text, our form with a text area and a form submit button here, text area, form submit button. And there's something happens when form submit is true, and then something happens when there's something inside ST session state called LLM answer. I didn't tell you, but anytime you interact with a Streamlit widget like this text area and I save, Streamlit will rerun the script from top to bottom. But here I don't want my Streamlit script to immediately rerun anytime I type into this text area. To prevent from rerunning, I create a Streamlit form. Any interaction with a widget in a Streamlit form won't rerun the script from top to bottom. So I can freely type in there, and if I want Streamlit to rerun the script from top to bottom, I click on this submit button. When I click on this form submit button, Streamlit reruns the script from top to bottom. So when I come to this text area, this value here is stored inside user prompts, and then if I continue running from top to bottom, this form submit button now becomes true. Because I just interacted with the button, it's now true. Now this is true, so I hope you just saw the spinner here. This spinner comes from this spinner line here. And then we call a form callback here with an argument user prompt. So if I go to this form callback method, you will find I use a client extracted from ST session state at the client key, which contains my Google Gemini model. And then I generate content using Gemini 2.5 and as content the user prompt. I store it inside this response variable, and then I store it inside ST session state. This value here was initialized at none at the beginning of the script. So if LLM answer does not exist, set it to none. But now it's got an actual value here. So coming back at the bottom of the script, now this has a value. I extract this session state LLM answer inside a new variable just to type it. And now that it has a type, I can freely see what's inside there. I can see all of the generation candidates from Gemini. I can see all of the function calls, the model configuration, or the actual content of the response. The content is inside the text variable, which displays here. Here's the breakdown of the user query. My new username is Fanil. This is your very basic Streamlit script. And now I do want to output JSON instead of random text. Oh, before going to the structured output page, let me show you how to do this button in the bottom right. Going back to my main entry point in Streamlit App, you will see here I put a CSS hack. I target every widget with the CSS class of stPageLink, and I fix it to the bottom right corner. Going back to the web tools of my web application, if I select this button, how can I show it to you? This button is inside an stPageLink. Every widget from Streamlit has a dedicated CSS class, so you can easily target them like this stPageLink. I can target it from CSS, and this is going to run for all of the page links. If I actually remove it, you will see my page link goes back to the top of the script, which is normal because the page link here comes before the title. Let me show you back the HTML and then head to the structured output page. In my structured output page, I've got to define a schema for the generation of my JSON. We use Pydantic to model the schema output of the JSON by using a Python data class. Here you see the call reason with the name as a string, the phone number as a string, the reason for call as a string, and then I display it into the UI by using the with stecho method. And then because I don't want to show it every time, I hide this inside an expander here. So you've got your expander, and then I click on it, you can see the stecho of the call reason appears here. Now let's hide this back and see this form again. Let's go back to the form. You've got your form here with the text area and the form submit button. And after the form, you will see the st session state of schema answer, which was initialized as none at the beginning of the script. If I click on the button, it runs the spinner and you see my name, my phone number. But Fanil, why are you using an on-click callback here when you previously used if button here? There's a big difference between this button and this callback. When I go to this LLM page, whenever I click on this button, I generate a new rerun from top to bottom, and it's my responsibility to make sure that the callback is called at the right moment to put the answer inside session state. So it can become a little tricky when you have more widgets to play with. But using this on-click callback, I am sure that Streamlit runs this stform callback before rerunning the full script. So here, when I click on the submit button, it immediately calls this stform callback and generates a new response from the Gemini model client and stores it into the schema answer before rerunning the whole script to display the actual result at the end. Now you will see I also use my call reason pydantic class in the response schema to define the JSON that is displayed at the end. I also changed the input arguments for the callback. If I go back to the form callback here, you see the arguments. I define a new widget input key and a spinner placeholder. Now, my spinner placeholder is displayed after the form. If I submit, you see the spinner comes after the form. To modify the order of my Streamlit widgets, I use Streamlit placeholders. So I've got my form placeholder as an empty placeholder and my spinner placeholder as an empty placeholder. So my form placeholder will be here and my spinner placeholder will be here. Next, I put objects inside my form placeholders by calling Streamlit methods directly on it. I create a new form in which I put my text area and my form submit button. I create a new widget input key and I use this to provide a new key to my text area. So here my key is schema out input. It can be like this instead. And then I send both this key and this spinner placeholder as part of my Streamlit form callback. And now I can use my spinner placeholder to display a new spinner while I'm generating content. So here, spinner. And as content, I go fetch the widget input key from st session state. And this is because any Streamlit input widget, like this text area, whenever it has a key associated, the value of the text area is synchronized in session state in real time. So when I change the content of this text area with my name is Fanil, this will immediately be stored inside st session state at the key of widget input key. So I can retrieve it from my form callback in st session state to run the callback with ease. There you go. This is how you use Streamlit callbacks to make calls to Google Gemini, but by still showing spinners at the exact location you want it to be displayed in the UI. Okay, we can send JSON schema definition to the LLM and it answers with a JSON. But how about we send function definitions to the LLM so that it answers back with a function that I need to run on my side? So we jump to function calling. Function calling, function calling, function calling. For function calling, we create a set of functions like get current balance and edit balance. Each of those functions interacts with a CRM session state. Here you can see inside my session state, I've got a Fanil with 500 and Alice with 1,000 euros. This was initialized at the start of the script with the LLM answer. And then here you got your ST session state, fcall CRM, get the name or the customer not found. And then here I can edit in edit balance, I can edit my session state with the amount that is inside the argument. After defining those functions here, I inject them as tools inside my client generate content. Google GenAI will automatically extract the function definitions and the argument documentations to send it to the LLM. So when I submit on the button, here it's the same structure. I got a form with my widget input key, my text area, and my form submit button. When I click on the button, it first reruns the ST form callback. So I got my spinner that runs, then my generate content using those functions as tools, and then I store the response inside fcall answer. Going to the end, I extract the fcall answer inside the generate content response. That way I know that it has a text method here. You can type text. And if I want to analyze the full response to find out which function was called back by Google Gemini, I can display the whole object st_right of fcall answer. So you got your candidates where Gemini can generate multiple suggestions for the prompt. You got your create time, usage feedback, and here your automatic function calling history. In there you will find this one is empty, but this one here is a function call with 4 arguments named Fanil, and the method will be get current balance. The function response is none because here the LLM asks me to run the function get current balance with the arguments of Fanil. So I run it on my side. The answer will be 500. I send it back to the LLM, and the LLM sees the result 500 and uses this as part of the final generation. Now all of this is done automatically. I can actually disable this to do it manually, but I don't want to do it for now. And this is how I extract the functions that were called get current balance with arguments named Fanil, and then I describe and extract the function call name and the function call arguments to showcase them to you. Finally, I've got my ST toggle to show the content of session state, just to show people that those functions are actually called by the LLM to edit Python states. This tools argument here for generate content, this is where I plug in or extend functionality for the LLM from functions to actual RAG. So it's time to jump to retrieval augmented generation. Before going further, let me show you Google's RAG engine. I enabled RAG engine inside my sandbox project. I created a new corpus of documents that I want to embed inside a vector store. And inside this corpus, I imported data from the 2025 WEF jobs report. Now I can load this RAG engine corpus in my Python code. Here I initialize in ST session state, I initialized my RAG corpus. If I cannot find one, I put a big warning. And then I initialize RAG engine in Python as a tool, a RAG retrieval tool. I store this tool inside session state, so I'm able to call it from my Streamlit form callback here. Here's my tool here, and here is my tool. The rest is as always. If I go back to my form area, here's my onClick st form callback. It will call Gemini using the RAG engine as tool. It will store the answer in session state, and I can analyze the session state again. I get the text. I know that this text is the first candidate, so I extract the candidate 0, and I look for the grounding metadata. I store it inside a variable, then I analyze each grounding chunk from this metadata. So here's the response from the method, and here's my chunk coming from RAG engine. So I've got 5 chunks. This is the first chunk, the second chunk, and the third chunk, each displayed from the grounding chunks from grounding metadata. That's what I like with Google GenAI. I know if I want to extend functionality with RAG or with function calling, I kind of know I have to put them inside the tools arguments here. Google GenAI tools can go all the way down to connecting it to an MCP server. So let's create one. Here I create an MCP server using the FastMCP library. Inside this MCP, I put a getGreeting resource that says hello from FastMCP resources. There's a getBalance method and an editBalance method as MCP tools, and an askAboutBalance as an MCP prompt, like can you please tell me how much money this person has. This is the moment where I fake the demo a little. In the previous code, my getBalance and editBalance were linked to st session state. The thing is, MCP from FastMCP runs by using Asyncio. So when I display the contents from the MCP server, like this resource and these tools, let me go to the expander. You will see here for resource in resources, here it is, the tools are here, and the subheader is here. For resource in res, or for tool in res, or for prompt in res, those are all located inside this res here. And this result is an Asyncio loop that runs the list MCP method. This list MCP method, I create a new client to the MCP server. I ping the MCP server, and then I list the tools, list the resources, and list the prompts. Finally, this Asyncio loop is stored in session state at the start of the script. So you will find it here. If there is an Asyncio loop, store a reference to it inside st session state. Otherwise, create a new one and store it in session state. Because of this setup, the Streamlit event loop and the Asyncio event loop are most of the time not the same. You can make it the same, but it will make it a bit difficult to manage when you have only 2 days to do those demos. A Streamlit event loop contains the Streamlit session state and Streamlit widgets, and you cannot call those objects from the Asyncio event loop. I would have to store those objects in an SQLite database or a remote database, but I did not have time to do this. So let me fake those demos a little. Now that I got my MCP server that works with an Asyncio loop, I can go to my st form callback. In my st spinner, I retrieve the Asyncio event loop, and I use the Asyncio loop to run the generate with MCP method by using the content from session state, which is the content from the form. This generate with MCP runs inside an Asyncio loop, and I create a new MCP client connected to the MCP server. And then since I'm in an Asyncio loop, I use an await on a client as asynchronous model generation. So you can see it with this AIO prefix. I use the user prompt that comes from this st session state. Here it goes into user prompt. And as told, I use the MCP client session that is connected to the MCP server. And now when I run this submit, it calls st from callbacks, which calls generate with MCP, which calls this generate content asynchronously. It stores everything in the MCP answer. And now at the bottom, as always, I've got my MCP answer. I use Markdown to display the answer, and Fanil has 1,000 euros, which is the actual content from the MCP server. Fanil's balance is 1,000 euros. Too much Markdown text. Now it's time to send some video, some image, some audio. So jumping to multimodal. A multimodal example is fairly easy, way easier than everything we saw so far, because we create a Streamlit audio input here, we create a file uploader to upload a photo, and then we got our text area that is here. And if any of those widgets are empty, I don't run the Streamlit file. So here, if this is empty or this is empty, then stop the Streamlit here. So don't run everything that comes here. So let's add something here. Let's put a new audio, a microphone. Hello! There you go. Now this has audio content. And let's browse for an image, a fridge image. And now we don't stop here anymore. This is not run, and we can go to the next part where we have the audio input get value inside a part, and upload image inside another part, and a user prompt inside another part. And now all of this is sent to the LLM as part of a list of contents to use. So we use all of the audio, the image, and the prompt into the generate content. I don't use a callback because I was way too lazy in this example. And finally, we got our response text. Hello, I'd be happy to describe the audio content, the image content, and that's a lot of image content. I'd love to know how it comes to these results. So if I want to analyze the inner thoughts of our model, I can go to my reasoning page. Let me go reasoning. And this is the same. So there's some image. So there's a title, an image with markdown. There's a blue prefix to put blue text that's Streamlit specific. And as always, as I've got a Streamlit form that contains a text area and a form submit button. When I click on this button, it goes to st from callback first. It calls the Gemini model with a new argument for thinking configuration where I tell it to include the thoughts. I store everything in session state in the reason answer key. And now that there's a reason answer, I extract it inside a reason answer of type generated content response. I put the final answer in here. Here's the extracted information. And in a new expander, I put the content of the first candidate. There's a content part 0.text that apparently displays the reasoning thoughts. If we want to be sure of it, I can st write it for you. Reason answer save. Here in candidates, you see the first candidate. There's the content. There's the text answer. All right, here's how I'm going to tackle this. This text actually contains the inner thoughts of the model. And you can, let's up. Here's the reasoning thoughts. All right, here's how I'm going to tackle this problem. Let's dive into the provided text. My name is Fanil. Bingo. Phone number. Finally, I'm happy. Next step. Quick review. This is how Gemini 2.5 reasons around the problem. Now we have LLMs that are able to reason around problems. They're able to analyze image, sound, and video. and they are able to select from a set of tools from MCP servers or the function tool definitions. I initially wanted to build a multi-agent demo with Streamlit, but honestly, in 2 days it was too much of a hassle to build all of the ST session state that connects to an MCP server or subagents and display back into a chat. So instead, I'm using another Google library, which is called Google ADK or Google Agents Development Kit. Let me show you the demo. Do I still need Streamlit, by the way? I'm going to for now. And then I go to the source folder and run the ADK web. This runs a new Google ADK UI. Here you will see the UI for a demo agent, and I can talk to it, hello, and it will connect to a Gemini model to get the answer from Gemini 2.5. Hello, how can I help you with? I can assist you with searching Google, which is a tool, as actually it's a Google search agent as a tool, or querying public datasets in BigQuery, which is another tool. Oops, let us show back. Let's go and look for the code. I'm closing my Streamlit app folder and opening my source folder. Now in this source folder, I have a list of agents. Right now I've got only one agent, it's demo agent, and I will find this demo agent here. Inside this demo agent, I've got my environment variable that again defines the Google Cloud project, the Google Cloud location, and whether to use the Vertex AI project or not. Then I've got an init file to import .from agent. This is necessary for ADK web to work correctly. And finally, I've got an agent file with all of my agent definitions. Before interacting with the demo agent, I need to define the tools that it's going to use, the BigQuery tool and the search tool. Those tools are built inside Google ADK. That's what you get when you're fully committed to Google. So we got a first agent here, our BigQuery agent. It's a specialist in BigQuery public datasets, and it's connected to a BigQuery toolset that provides it with 5 tools. I think there's a tool to list all of the datasets. There's a list all the table tools. There's a list the metadata for the dataset and the table, and there's a tool for running a SQL query on a table in BigQuery. This BigQuery toolset needs authentication to run, so here I'm using my Google own account, but it can also be a service account that you define from Google console. And there's a tool configuration that blocks any inserting that I do inside BigQuery. So if my agent generates an insert values into the table, this is going to prevent it. It's also good to use a service account here that limits the tables that you can access so that your agent is not able to query from every table inside your project. And then you've got your search agent here with a Google search that is coming from Google ADK. Now that you've got an agent for searching and an agent for BigQuery, you define both of those agents as tools for your root agent, which is your demo agent. By the way, instead of using agent as tools, you can actually define sub-agents as a list of agents. So you can put your BigQuery agent here and your search agent here. So the way it works is if you're using sub-agents, the root agent is going to pass the thinking to a sub-agent, the full thinking. But if you're using a tool, the root agent is going to delegate some thinking to the tool, but you know it's going back to the root agent. Now that we have this, we can actually search for the latest Streamlit version. The agent here is going to look into its tools if there's a tool to search for something on the web. It says yes. let me put this in full screen, by the way. And here, the latest version of Streamlit is 1.47.1. And now I can open my tracing graph and see that my demo agent is using the search agent, which has a tool for searching on the web. The search agent is going to look for latest Streamlit version on Google, find an answer, and then output the answer inside the LLM. It is going to summarize this into the latest version of Streamlit is 1.47. There are a lot of functionalities in Google ADK that I like. You can trace everything that's happening here. There's an invocation that calls a run agent that calls a tool. You can find the tracing of the tool. You can find all of the events. You can store state. It's like session state, but for Google ADK, so that you can share session state between tool callings. And there are artifacts here where you can store bigger objects like images or datasets that you want your tools to call. All of this is provided by default from Google ADK, and now you understand why I don't want to implement all of this in Streamlit. It's way easier to showcase the thought reasoning from this UI. I don't have to code anything in 2 days. I'd love to make a dedicated MCP video or Google ADK multi-agent system video. Just comment below if you want to see one. And the link to the GitHub repository for all of this code is also in the description below. Otherwise, I'll see you around. Bye!